3.2 Applications of Maxima and Minima. Problem number 3. The cost of making X items is described as 72 plus 5x plus 0.02x squared dollars. We want to find the price that minimizes the average cost and the average minimum cost itself. First, let me describe a little bit about this equation. What about this equation is probably saying. This is your cost. 72, since it's a constant, that's probably the cost that it takes just to set things up. So let's say you're going to go to a venue, you're going to sell hot dogs. $72 is probably the cost to pay the tickets to get into the place, maybe to be a vendor, but it's just an affirmed cost. Then the 5x is probably the cost of each item. So it may cost you $5 a piece to get these items, say hot dogs or whatever that you're selling, but it's costing you $5. Plus there's a 0.02, that's like about a 2% cost that's kind of creeping in. That's items being lost, burnt, items that didn't work out, customers didn't like. So that's also costing you, so it's about 2%. And we want to ask ourselves, how can we minimize our average cost? Well, first let's describe this as cost. Based on x is 72 plus 5x plus 0.02 times x squared. So let's say this is $500 of cost and you've produced 10 items. Well, the average cost takes the 500 items and divides it by 10, so it comes out to be $50 per item. So average cost is saying how much are we spending per item. So since this is a cost function, we will describe the average cost function with the little dash on top there as the amount that we're paying divided by all the items that we are working with, which are X items. And I want to minimize this, so I need to take a derivative of the average cost function. What I want to do is I want to simplify this by dividing everything by x and getting powers of x next to each term. So dividing each term by x gives me 72x to the negative 1 power plus a constant of 5 plus 0.02x. Now I'll take the derivative of this. And to minimize this function, we're going to set it equal to 0 and solve for x. So I did forget to subtract 1 from the exponent here. So this will be x to the negative 2 power. Okay, now to solve this, I want to get rid of all my negative exponents, which is the x to the negative 2nd power. I'm going to do this by multiplying everything through by x squared. Now that I have 0.02x squared minus 72, I'm going to divide both sides, so all terms, by 0.02. this gives me 0 equals x squared minus 3600. There's several ways I can solve this. I'm going to use factoring because it seems to me this is a difference of two squares, and I can solve by using the conjugates. Okay. When I set both these factors equal to 0 and solve for x, I'm going to get two solutions. Since the domain of this function is x, represents items, we cannot have negative items, so therefore we use x is 60. So x, or 60, items would be the number of items that we'll need to make that will minimize our cost, or should I say that's the number that we actually need to sell, buy and sell, and our cost will be minimized. Now, what is that average minimum cost itself? Well, let's find out. Let's take our 60 items and place this into our cost function, and we can find out how much of this is costing us. So C of 60 items is going to equal 72 plus 5 times 60 plus 0.02 60 squared. Alright, 72 items here. This will be 300, well, our cost is 300 there. This is going to be a 0.02 times 3600. Okay, I'm going to reduce my zeros by 2, so here. That ends up being 2 times 36, and that's going to be 72, plus my other 72, plus my 300. And the 72s will add up to 144. So 144 together with the 300 gives me 444. So this will be my average minimum cost.